Alright, hello everyone. My name is Daniel. I'm a final year medical student and I'm the co founder of the USMLE Forum of Pakistan. And in this topic, we're going to talk about cellular injury. And this topic is a continuation from our previous video. And we have been discussing about the foundation pathology. Alright, so first of all, let's imagine this. A cell is a living space, and a cell is living peacefully, producing ATP, maintaining ion balance and synthesizing proteins. Now, suddenly, if somehow oxygen supply drops, within seconds ATP starts falling, and within minutes cells begin to swell. And if injury continues, membrane ruptures, enzymes spill out, and the cell dies. Now, today we are going to understand exactly when a cell can recover and when it crosses a point of no return. So let's break down the cellular injury into powerful categories. So first of all is the reversible, and the second is gonna be the irreversible type of cellular injury. So now first of all, I'll talk about what is cellular injury and why do cellular injury occurs. So first of all, cellular injury occurs when a stress exceeds the cell's adaptive capacity. Normally, cells adapt and the adaptation is in the form of hypertrophy, hyperplasia, atrophy, metaplasia. But when the stress is too severe or prolonged, injury occurs. Now, the major causes of cellular injury, and those are mentioned here. And let me show you an illustration of that as well. And that is that it can be the cellular injury can be due to hypoxia, which is the most common cause of cellular injury. It can be in the form of ischemia, and it can be as a result of toxin. It can be as a result of infection, immune reaction, nutritional imbalance, and physical trauma. So all of these things will lead to ATP depletion, right? Everything like hypoxia, infection, toxin, immune reaction, whatever the thing is, it will lead to the uh, depletion of ATP. Now, when the cellular injury occurs, if the fate of cell is now death, and the death can be in the form of apoptosis or it can be the form of necrosis. We go into the detail of that in the next lecture, but right now let's confine ourselves to what is cellular injury and what is reversible and what is irreversible cellular injury. So now, first of all, let's start with the good news. So, reversible injury is that the cell is stressed and it can recover. So, the cell is damaged but can recover if the stress is removed. Now, what is the earliest and the important event of the reversible cellular injury? So, the decrease in ATP production and which is again most commonly due to the hypoxia. So when the oxygen drops, or somehow, whatever the cause of cellular injury is, either it can be trauma, hypoxia, toxin, infection, immune reaction, nutrition imbalance, whatever. So when the oxygen drops, so everything leads to the depletion of ATP. So let's talk about we are taking hypoxia as an example because it is the most common cause. But everything, let me clarify it. Everything can lead to the ATP depletion, right? So let's talk about the hypoxia. We're considering hypoxia as an example. So when oxygen drops, let's suppose in the state of hypoxia, so oxidative phosphorylation decreases and ATP decreases. Now, ATP depletion triggers multiple problems. First of all, there is sodium potassium pump failure. Sodium enters how the sodium potassium ATPs pump work. So the basic function of this pump is to remove out sodium out of the cell and pump potassium into the cell, and this would lead to the extracellular fluid, fluid of high sodium, and the intracellular fluid, a fluid of high potassium, right? So the basic function of this pump is to pump out sodium out of the cell and pump in potassium into the cell. Now, if this pump fails, so the sodium, you're going to retain a lot of sodium within the cell. Now, actually, water is really attracted to sodium. Wherever there's sodium, there is water. So sodium is now retained into the cell. Now, as I told you that water loves the sodium, water follows the sodium. So water follows into the cell, and this would lead to the cellular swelling. Now, this is something called as hydrophic change, and I'll explain this into the microscopy as well. So, this is a hydrophic change, not hydrophobic. It's a hydrophic change, and cell becomes puffy, but the cell is still alive. Now, if there is decreased ATP production, the cells start shifting into the anaerobic glycolysis, and this also leads to the lactic acid accumulation, decreased pH, and there are some chromatin changes within the nucleus of the cell. And also there is ribosomal detachment, because again the ribosome is swelling, and the endoplasmic reticulum is swelling, and if the endoplasmic reticulum is swelling, then ribosome is detached from it, and this leads to decreased protein synthesis. Now, in the liver cell, you may also see some fatty changes. So let me show you a light microscopy changes. So first of all, keep in mind that the light microscopy changes are cellular swelling, the hydrophic change I told you, and the fatty change that is especially seen in the liver. So let's say it's a hepatocyte, and you can see that these cells are swelled up. You can see the swelled up cell, the hydrophic change into the cells. So these are the common changes that can be seen into the light microscopy. Now, the changes that are seen in the electron microscopy are the mitochondrial swelling, the membrane blobs, the ER dilation, endoplasmic reticulum dilation, and chromatin clumping, which I already explained to you that by there are chromatin changes, right? So let me tell you again, the chromatic changes are just because there is a lot of lactic acid accumulation, and there is because of anaerobic glycolysis, and that lactic acid accumulation decreases the pH, and this pH actually degrades and clumps the chromatin, and that's what you see on the electron microscopy as chromatin clumping. So now you can see these what you say these electron microscopic changes. This is the normal endoplasmic reticulum, but now this is the swelled up endoplasmic reticulum, and the reason I explained it why there is swelling of the endoplasmic reticulum, because again, even in the endoplasmic reticulum we have ADP channel, sodium potassium ATPase channel, and again they are not working. If they are not working, so the endoplasmic reticulum will also swell, and the results are in front of you. So you can see the air dilation. I'll explain it to you. Now there is something you can even, in fact, the mitochondria can swell, because again, the same strategy. You don't have sodium potassium ATPase pump, everything's gonna swell. If you have, just keep one principle in your mind. Whatever I'm discussing here, try to make principles. When I was a step one, a step two CK student, my main strategy was just to make principles out of the stuff. So when you make the principles, you make the things easier for you, no matter which subject you are studying. All right. So now let's get back to our discussion. So we were discussing about the yeah. So we were discussing about the changes. So yeah, I was saying that whenever there is ATP depletion, it will lead to the swelling. Whether there is ATP depletion in the cell membrane, whether it is in the mitochondrial membrane or in the ER membrane, endoplasmic reticulum membrane. Anyways, so another thing that you might appreciate here is the membrane blobs. Don't focus on these graph. Just ignore them. So yeah, you can see the membrane blobs over here, and these are the membranous swelling. You can see the membrane blobs when there is in the reversible cellular injury. So these are the important microscopic and like electron microscopic feature. So you're gonna remember these changes, and these are very high yield for your USMLEs and for your exams, right? So now let's move on to our. Just keep in mind that throughout this reversible injury, the most important thing for you to remember is that in the reversible cellular injury, the membrane remains intact. The basic difference between the irreversible and the reversible cellular injury is that in the reversible cellular injury the membranes remain intact, but in the irreversible cell injury your membrane won't be intact anymore. So let's talk about the irreversible one. So now, so what makes this irreversible? So now let me explain it to you. If the injury persists for two major events, let's if the injury let me explain it to you. If the injury persists, right? we were first in the land of the reversible cellular injury, but now the injury persists, the stress persists, right? So now the two major events make the irreversible cellular injury. The two major events make the reversible cellular injury irreversible. So first of all, the inability to restore mitochondrial function and the severe membrane damage. Now, let me explain it to you. Once mitochondria cannot generate ATP, the recovery is impossible. Let's suppose you have, as I've explained it to you, that in the in the reversible cellular injury, endoplasmic reticulum will be damaged, the mitochondria will be damaged, the cell will be damaged, the cellular membrane will be damaged. Now, if you injure mitochondria to a certain limit and to such extent that it cannot generate ATP, then the recovery is impossible for the cell. The cell cannot recover. Same goes for if you now the other aspect of this is that I told you that there are two events. The first event is the severe mitochondrial damage, and the second event is the severe membrane damage. If the membrane damage is there, then you are in the land of irreversible cellular injury. So whenever someone talk about the irreversible cellular injury, the two things that should click your mind is the cellular mitochondrial damage and the membrane damage. That's it. Now I'm going to come towards the second point, which is written over here, the massive calcium influx. So normally intracellular calcium is highly regulated. Now if you are damaging the membrane, right, so you are allowing the calcium to flow into the cell, and now during injury, the there is a channel, or there is a pump in the membrane that is ATP dependent, and that pump is responsible to pump out calcium out of the cell, right? So now what actually happens is that during injury you're not producing ATP. During injury your even membrane is damaged, right? So during injury you're not producing ATP, and those ATP pumps that are responsible to pump calcium out of the cell fails. Also, during injury your membrane is also damaged, and this is also allowing the calcium to flow into the cell, and this is how calcium accumulates inside the cell, right? So what actually happens as a result of that excess calcium activates the destructive enzymes. Now, when there is excessive calcium inside the cells, when there is excessive calcium inside your cell, so this actually activates the destructive enzyme, and again, as it is mentioned here, that this is gonna activate phospholipases, which damages the membrane. It's gonna activate the proteases, which gonna break down the cytoskeleton. It's gonna activate the endonucleases that gonna damage the DNA, and it's gonna activate the ATPases that gonna worsen the ATP depletion. Now, at the same time, as a result of these as a result of these activated enzymes, these enzymes break down these components of the cell, and as a result of their breakdown, the reactive oxygen species are formed. These reactive oxygen species, again, the ROS, gonna damage your lipids, they're gonna damage your protein, they're gonna damage your DNA. Now, there are some antioxidants in your cells, which are vitamin E, C, glutathione, and catalase, and if they are present in your body, if they're present inside your cell, then then they're gonna help you out. But if your body are deficient, like for suppose in the elderly individual, glutathione is less. So let me give you a relevant point to this. Let me just give you a brief overview. I'm not going into the detail of that. You might have heard about a medicine that is called as acetaminophen, right? That is called as acetaminophen. So now this acetaminophen actually produces a lot of free radicals inside your liver. Somehow it produces ROS inside your, or somehow it produces reactive oxygen species inside your liver cells. Now, in the elderly individual, now first suppose people like you and me, like someone who is younger, or someone who's young enough, got a lot of glutathione inside the liver that can actually fight off those free radicals. But when you are in elderly, when you are an elder individual, so there is low level of glutathione inside the liver, and you are more prone to get damage from those reactive oxygen species that are formed as a result of in taking the acetaminophen. So that's a relevant clinical relevance from that. Even if you don't get it, that doesn't matter. But you should remember, but you should understand that the free radicals, sorry, the antioxidant play a vital role in neutralizing those free radicals. So if your body is having is deficient in vitamin E, C, glutathione, or catalase, something like that, so your body is prone to being damaged from these free radicals. Now, get back to our topic. So, what actually happens that I have told you about the ATP depletion, and I've told about the calcium influx, and yeah, we're good to go. Now, I want to explain you about something regarding the nuclear changes and their exam goal. So, there are a few nuclear changes that gonna happen, and I would like to explain you these things from these easy figures. So now, first of all, I've told you about the cellular changes that gonna happen um, in the irreversible cellular injury. The membranous changes, like the membrane gonna rupture, like uh, I've told you that that the mitochondria is gonna damage, and ER was already damaged. So the big picture is just the the that your the big picture is that your membrane is damaged, and your mitochondria is damaged, that most of the membranes of your cell and the cell organelles are damaged. Now, what is more important for you for the exam purposes is that you must remember the nuclear changes within the irreversible cellular injury, and and the nuclear changes are, first of all, the epignosis. So in the pyknosis phase, there are three phases of the nuclear changes: the pyknosis, and the karyorrhexis, and the karyolysis. So in the pyknosis, the nucleus shrinks and becomes dark. In the second stage, the karyorrhexis, the nucleus become fragmented. And in the last phase, the nuclear karyolysis, the nucleus dissolved due to the DNA's activity, and that's it. So once you see these changes, the cell is dead or dying, and that's it. Alright, so now there are core mechanism of the cellular injury. Again, I have explained these things again previously, but I'll just sum it up. So there are five fundamental mechanisms: ATP depletion, mitochondrial damage, calcium influx, reactive oxygen species, and membrane damage. Everything in the pathology come back to these five. Master them, and you're gonna master cell injury. Now, I have some clinical correlation for you that in myocardial infarction, from 0 to 20 minutes, the cellular injury is reversible. But if the blood flow returns, the myocardium recovers. But if the injury, or if the blood supply uh, is shut off, if the blood supply is closed, if the myocardium is not getting the blood supply, the heart muscles not getting blood supply for more than 20 minutes, 20 to 40 minutes, then the myocardial muscle ruptures. Sorry, the myocytes of the myocardium ruptures, their membrane ruptures, and they enter into the irreversible cellular injury phase. And when there's membrane ruptures, some you can say some components of the myocardial cells leak out, and those are called troponin. And you check those troponin in the blood, and if their levels are raised, then it means that the necrosis has occurred and the cell has died. So that's why early reperfusion therapy saves the myocardium. Time is equal to ATP. In the case of cellular injury, what I always think is just like that time is equal to ATP, and ATP is equal to survival. So I've explained everything to you in this topic, and we are done. So just keep in mind, remember this: the cellular injury is not just about damage; it's about threshold. As long as the ATP is recoverable and the membranes are intact, the cells fight. But once the mitochondria collapse and the calcium floods in, the point of no return is crossed, and the cell death becomes inevitable. So in pathology, survival is measured in the form of ATP. That's it from my side. Hope you understand this lecture, and follow TFOP for more content. We also give on the one-to-one tuition classes and mentorship, and there are different plans for that. So you can contact us on our Instagram page and via directly. Uh, you can also comment down for the mentorship and tutorship program in the comments. We will get back to you as soon as possible. We have mentored a lot of students, and many students passed their step 1 and CK recently under our mentorship and also our tutorship. So contact us for more. Thank you.